we figure out our resultant, and then it says degrees clockwise relative to the north.
Generally speaking, if somebody gives you a compass heading, that's one way to do navigation. North is 0, 360, depending on which way you want to look at it. And all the degrees are measured. That's 90. This is 180. This is 270. In a maritime situation, first generator study on course 232.
Right.
That's what you'd say to the Navy if you're giving command. So, counterclockwise from north. Is that?
No, you see, well, that would be clockwise. Counterclockwise would be some of the other ones, but...
Oh, does it say counterclockwise? It says clockwise.
Right.
I said counterclockwise. This says clockwise.
Right.
I was kind of right. I
But it
didn't.
says air rushing past the void. I guess it would have to go in the opposite direction of the resultant.
Basically, what that said, air rushing past the void, that's the relative velocity. If you had a wind speed meter, like on top of like a weather station, if you had a weather vane and a wind speedometer, it would measure the relative speed. The wind speed that the void feels is another way to say that. Let me give you some simple examples before we go any further. Let's say you're on a bike. Well, that's a weird looking bike. I don't know. Got wheels on your feet, whatever. And you are moving at a velocity of 5 miles per hour. Okay? Now the wind is going this way, 5 miles per hour. What wind do you feel on your face?
10 miles.
10 miles per hour. That's the trivial case. Or likewise, if the wind is going this way, this is almost worse. If you're biking, wind at 5 miles per hour. What do you feel in this case? 0. You just die. It's so hot. You can't breathe. You just burn up because you've got no wind to cool you down. So this is a sample of that. So when he's asking for the air rushing past the void, it's the relative velocity of the wind apparent to the void. Okay.
But that wouldn't be reasonable, right? Because since the bike is moving, you'd be creating wind, wouldn't you? As you're moving, like the air.
But the wind is going. Think of the molecule of air. It's moving 5 miles per hour, right? So the bicycle. So it's just sitting there. You can see the molecule. You just get. Yeah, confetti, and it was floating, or a balloon. Think if you let a balloon and the wind's going 5 miles per hour. If you walk 5 miles per hour, you keep up with it.
So whenever it says, what is the speed, compass heading, degrees clockwise, I guess instead of giving counterclockwise, the reasoning for that would be, I mean, what's the difference? It's just going to be the difference of 360, between the two.
What is the speed? Compass clockwise relative to north. So generally when you give a compass heading, it's always measured from the north. It's just nomenclature.
Right.
So it's this clockwise measured this way. Mathematicians, they do it the other way. And there's no right and wrong, it's just which nomenclature you're using.
You just want that in this particular problem. Right. Okay.
Because if you're going to talk about a heading, generally they're measured in this direction. If it's on a mathematical graph or something, it's measured the other way. Just the way it is. I wish it wasn't the same. They're different directions and they start on a different axis. Just to confuse you all. That's the reason people do this. Just to torment students, I think.
In that case.
But most people, if you look at like you get your GPS set, what you're heading, it's using this nomenclature that's in this problem. So you're clockwise from north. That's what most people, that's kind of the normal thing to do. The mathematicians are the ones that have it weird, where they start here with positive x and measure backwards. So on this problem, this little boy, he's going. Let me get rid of some numbers.